All right, everybody, welcome to the video lessons on the axial skeleton. There are going to be 3 videos, and today we're going to start with the first one, and that's going to be just a general overview of the axial skeleton and what we're going to find there. So let's go ahead and get started. Welcome to the lecture video on the axial skeleton. Your skeleton is divided into 2 main categories. One is the axial skeleton and the other is the appendicular. So we are going to focus on this set of videos are going to focus on just the axial skeleton. So you have 206 bones in your body. And again, they are grouped into those divisions of the axial and the appendicular skeleton. So for our purposes here, the axial skeleton is highlighted in blue, and that is going to be the skull, the thorax, and the part of the pelvis, the very bottom, and of the spinal column, which is right there. And that will be the axial skeleton. The axial skeleton consists of the bones that lie around the longitudinal axis of the human body, the skull bones, the auditory ossicles, which are the tiny bones inside your middle ear, the hyoid bone, that is the only disarticulated bone in your body. It does not articulate with another bone. It is free floating, and it provides the framework for your larynx or voice box, your ribs, the sternum, aka the breastbone, and the bones of the vertebral column. The appendicular skeleton then, of course, would be all of the other bones on your body. Primarily, you're talking about your arms and your legs, so your extremities, and then the remaining part of the pelvic girdle would also be considered the appendicular portion of your skeleton. Types of bones. Each of the 206 named bones of the axial and appendicular skeletons can be placed in one of 6 broad classifications based on their embryological origins and their anatomical characteristics, primarily their shape and what they do and what they are used for. Long bones, the name is pretty self-explanatory. They are greater in length than they are wide. They are often slightly curved for the purposes of weight bearing. Their strength in arches. Examples include the femur, the tibia, the fibula, the humerus, the ulna, the radius, the metacarpals, the metatarsals, and your phalanges. Short bones would be just the opposite of the long bones. They are more cube in shape, and they would include your carpals, the bones of the wrist, and the tarsals, the bones of your the back or posterior portion of your foot. Flat bones are thin and composed of 2 nearly parallel plates of compact bone enclosing a layer of spongy bone. So you'll find in flat bones, there'll be no medullary cavity as you would find in long bones, which we'll talk about here shortly. They include the cranial bones, the ribs, the sternum, the scapula, and clavicles. Irregular bones include complex shapes, similar to the vertebrae and some of your facial bones. And sesamoid bones vary in number and protect tendons from excessive wear. The best example is the patella. A sesamoid bone can develop fractures due to friction, tension, and stress. So the patellar tendon is attaches the muscles of the quads, and it will go down and attach to the tibia, and it will encase the patella, and that patella then there is used to protect the tendon from excessive wear, because that's a pretty can be a pretty rough place to bend, as that tendon is stretched over the surface of the knee as you bend your leg. Sutural bones, these are going to be the bones of the skull, and they are called sutural bones because their articulation is a suture, meaning it is an immovable joint. Sometimes these are referred to as Wormian bones, named after good old Dr. Wormian. They are small extra bone plates located within the sutures of cranial bones. These are found as isolated examples, and although unusual, they are not rare. So, for example, most of the time, there is just these, in this point, there's just these three bones. The occipital bone and the two parietal bones meet in a three-way portion right there. But in this example, there are a couple extra plates of the Wormian bones. You can see there's one here and there's one there. Bones have characteristic surface markings, structural features adapted for specific functions, and that is what most of your bone tray quizzes are going to focus on. There are two major types of surface markings. There are depressions and openings, which is allow the passage of blood vessels and nerves. They will sometimes form joints. And then the opposite will be a process. And a process is any prominent projection that sticks off of or out from a bone. They serve as attachment points for ligaments and tendons. And we will talk a lot more about the difference between those two here in the upcoming lessons. While a process is any projection off of a bone, large or small, a spinous process is a slender projection from a vertebrae. Now, you will also find there are a couple other places where you can have a spinous process. The scapula, for one, comes to mind. There is a spine on the ridge of the scapula, so these are typically not found only on vertebrae, but you will find them in a few other places. A foramen is an opening in a bone through which blood vessels and or nerves will pass. So here we see a foramen in this one particular vertebrae, and it is referred to as the vertebral foramen. So this is where the spinal cord will run through that entire column of vertebrae. As we are looking at this from a superior view, or on top, looking down through that particular vertebrae. And then over here we have the intervertebral foramen, which this opening nerves will actually come out of the spinal cord and branch off and out of this opening. And this opening is made by two different vertebrae. Still, though, both a hole or an opening. So that's why it is referred to as a foramen. If a bony process is large, round, and articular, it might be called a condyle. Condyles of the humerus are the trochlea and the capitulum. An epicondyle is going to be a bony protuberance above a condyle. Remember, the prefix epi means upon or above. So the epicondyle is going to be above the condyle. A fossa is a shallow depression within a bone. So we see here some examples. This trochlea, this is a condyle. This is an articular surface at the distal end of the humerus where it will articulate with the semilunar or trochlear notch of the ulna. This is the capitulum, and that is the articular surface or condyle, the second at the distal end of the humerus, where it articulates with the head of the radius. And the olecranon fossa is this depression on the back of the humerus where your elbow, when you straighten your elbow out, the olecranon process will fit in that depression called the olecranon fossa. You'll call it olecranon, and I will correct you hundreds and hundreds of times, but it is the olecranon. A tubercle is a small rounded projection. So here we see the pubic tubercle, which is this small rounded projection right there. A tuberosity is a large bony prominence that is not articular. So it's not going to be up against another bone. A condyle is articular. A tuberosity is not. So a classic example here is the tibial tuberosity that sticks off the front of the tibia right there, and that's going to be the attachment point of your patellar tendon. The meatus, which you will pronounce meatus, that is not correct. It is pronounced the meatus, is a tube-like canal. The classic example that we look at is the external auditory meatus right here, and that is for your ear canal, so that sound waves may be funneled to your tympanic membrane. The trochanter is only found on the femur, and there are two on each one. You have the greater and lesser. The greater, of course, would be the larger, and the lesser would be the smaller of the two. And here you can see the greater trochanter, and this is kind of a bad angle because the lesser trochanter technically would be seen better from the posterior view. This is the anterior view, but it is back there, and we will point it out in due time. So these tables will give you a good idea of the markings, their definitions, and examples of where you can find them. So a fissure is a narrow slit or a crack between adjacent parts of bones through which blood vessels and nerves will pass. A foramen, as we mentioned, is a hole or opening through which blood vessels and nerves will pass. A fossa is a shallow depression. A sulcus is a furrow along a bone surface that accommodates blood vessels, nerves, and tendons. And then, of course, the meatus, and you can see the phonetic spelling is right here, meatus. So you do put the accent on the A, and that is a tube-like passageway. Processes, a condyle is a large round protuberance with a smooth articular surface. A condyle is where a bone rubs and articulates with another bone. And of course, then the epicondyle is going to be a protuberance above the condyle. So epi, again, means above. The facet is a smooth, flat, slightly concave or convex articular surface. The head of the bone is usually a rounded articular projection supported by a neck, which makes sense. That's why they call it the head, because it's supported by the neck. We already talked about the epicondyle. A crest is a prominent ridge or elongated projection. A line is a long, narrow ridge or border. A spinous process is a sharp, slender projection. The trochanter, very large projection, again, only on the femur. The tubercle is a variably sized rounded projection. And a tuberosity is a variably sized projection that has a rough, bumpy surface. All right, that's going to be it for video lesson 1 on the axial skeleton. All right, that's going to wrap everything up for the video lesson 1 on the axial skeleton. So as always, if you have any questions, shoot me an email, let me know, and we'll talk to you next time.